Alright, so today we will be talking about similar polygons. Okay, and I have a lot of vocab to talk about, but first off, let's start with the simplest one, a similar figure. It has the same shape, not necessarily the same size. As you can see with these two polygons, that actually matches up. Okay, alright, so same shape, not necessarily same size. Now, if you remember back to your congruency statements where we had SAS, SSS, ASA, AAS. Okay, we had two parts where you just didn't use congruency, and that was SSA and AAA. Okay, so these were not congruency. So not congruency, blah, blah, blah. But this one, oh shoot, the AAA we are actually going to be using right here. So this, we didn't talk about AAA, but we're going to be definitely talking about it today, where all three angles are actually going to be congruent. And we'll talk about triangles in a later chapter, but we will be using this. Now you're probably going to wonder, why do we talk about SSA if we're never going to use it? In trig, you'll actually learn the couple situations where you can use SSA. Okay, so trig is like advanced geometry. Okay, alright, so similar figures that. The similar polygons, okay, all corresponding angles are congruent. Now, if you notice, this isn't technically an AAA problem because there's four angles, okay, but in this, angle B corresponds with angle H, angle G corresponds with angle A, angle C with angle I, and angle J corresponds with angle D. Okay, and here's some statements I can say. Angle A is equal to angle G. Angle B is equal to angle H. Angle C is equal to angle I. And angle D is equal to angle J. Okay, so you can say those statements right there, as long as you note that these two are similar. And what you'll use is this little thing called a tilde. Okay, so you say tilde right there. Now, what you can also do is make a corresponding, well, not corresponding, but an extended proportion of these two. Okay, so if I knew that this was 4 and this was 8, and let's say this was 2 and this was 4, and you'll probably see a pretty good relationship here when you work with this 5 and this is 10, and let's make this 14, and this, let's make it 7. It doesn't look 7, but it is. Okay, so what we can do is we can actually rewrite all of the angles, and they're going to be congruent. Okay, but then when the shapes, when we're working with them, we're going to make an extended proportion, okay, of all these side ratios, and we're going to write them out. So we know that AB over GH, okay, we know that that is going to be equal to, so AB over GH, okay, and I just screwed up my own little rule. Okay, so first off, before we start working on this, let's go ahead. Let me just delete everything. There we go. Let's just delete that. Okay, you want to rewrite the shapes so they're going the same direction. Now, if you notice, my shapes are already going the same direction when I started, so I don't need to do anything. And then when you're rewriting the proportions, go from big on top to small on the bottom. Okay? Let me change that. Let's change that spelling just to go right there. Okay? So I'm going to follow my own rules. So what I'm going to do is I'm going to have these over here on top, and then I'm going to have these on the bottom. So I'm going to have GH over AB, okay, and I'm going to have them correspond to each other. So I'm going to have HI over BC, okay, and I'll put in the fraction bars and everything in a second. IJ over CD, okay, and JG over DA. Okay, And what's going to happen is that these are going to be 4 proportions. This is my extended proportions, and these guys are going to be equal to each other. Okay, and voila, I can use these to actually solve the rest of the problem. Okay. Alright, so everything's all set up and lined up into this. And now what we're going to do is going to talk about scale, scale drawing, and scale factor. Okay. Alright. So something right here. First off, before we go into the scale parts, what we'll actually do is solve this for x and y just by using this proportion. So now how do I know that these are actually going to be proportional? Okay. Well, if we know that these are trapezoids, which I will state, these are trapezoids, these are congruent, or I'm sorry, not congruent, but they're just trapezoids. Okay, that means that these two angles are going to be the same, and that this smaller trapezoid is going to share the lower left angle with this larger trapezoid. Okay, they're both going to be the same. So as long as I know that, I'm pretty much dealing with a really good object. And if I was able to extend this, these would be congruent, okay, and I would just go from there. Now I'm just going to say that this is a congruent type of shape. These two shapes are congruent. I'm sorry, not congruent, similar. So I'm going to go ahead and set up the proportions. So what you do is you go from big to small, so 12/9. Okay. Alright, and you're going to have on the top, you're going to correspond in the corresponding spot, 7.5 over y, and then you're going to have 10 over x. Okay, so we set up our proportions right here. Okay, so we have everything all set up. So once we have our proportions set up, then you can start doing cross multiplying to find certain ones. Now, you're not going to do cross multiplying with all 3 proportions. You probably do the first 2 first. Okay, so right over here I get 12y equals, let me see, 9 times 7.5 is 67.5. Okay, and then we divide that by 12, because that's how you solve the rest of it. And I'm going to get y is equal to 5.625. Okay, so now I actually know the actual measurement of this, 5.625. Okay, all right, now to get the x, what I highly recommend is use the one that you know without any decimals or anything, and then use this one right here. So what I'm going to do is solve that by doing the cross multiplying rule. Okay, so 12x equals 90. Okay, and then I divide by 12. I divide 90 by 12, and I should get 7.5. Okay, and voila. Magnifique. I actually have my whole problem set up. Now obviously these are not going to look the same, they're not drawn to scale, but in reality I just solved this problem and was able to figure it out by just solving some simple proportions. Okay, now in the beginning they do need to state that these two figures are similar and stuff, but for right now that's just what it is. Okay, alright, now you're going to also be talking about scale, scale drawings, and scale factors. Okay, now scale drawings you have already dealt with when you guys have worked with all this stuff, especially when you've worked in your social studies classes. Okay, but scale drawings, they can change quite a bit, like 1 mile corresponds to 1 inch. Okay, so for every inch you measure on a map, that's 1 mile in reality. Miles. So that would be a scale factor. Okay, so when you write out a scale factor, you have to go on what order it is. So it would probably be 1 mile over 1 inch. So you would have miles over inches as your proportion that you're working with. Okay, now if they had reversed it, you would reverse these as well. Okay, but a scale drawing, you just need to be able to take the understanding that you're going from with the drawing, you're going from a smaller thing to a larger thing, so you just need to pay attention to that fact. So if, for example, you know that for every 15 inches that is equal to 15 feet, okay, for right there. So if I have something that is, 20 inches, how many feet is that? Okay, now some of you guys can probably already see what that actually is. Okay, but what you would do is you would set it up as 15 over 15 equals 20 over x. Okay, and what you could do is cross multiply and actually solve for it. Okay, now some of you guys are probably recognizing the fact, oh wait, 15 over 15 reduces to 1 over 1. So if that's 1 over 1, then x has to be 20, and that would be an okay shortcut for you to use. But you do need to give the context of what you're actually finding. Okay, so when you're dealing with scale factors and scale drawings, just know, take your time, write out your proportions, you should be set. And that's it for similar polygons. I'll talk to you guys later. Bye.